invited special invitees and Chief General Manager from BCIL and scientist and expert from SEBA, Dr. Amba Shankar Garu. All the feed manufacturers, technicians, and progressive farmers, we welcome you to this webinar. We earnestly thank you for joining with us, given a very short time and duration. In fact, this webinar holds quite significant from the viewpoint of aquaculture and the challenges that we've been facing. So this mainly concentrates on genetically modified crops and its protein source that which we can use for the preparation of aqua feeds. As all of us know, AP state stands first in production of shrimp and fish production too. Though our state is a premier state in production, we have a few challenges as almost all the farming and farming sector is quite active and needs to be addressed on immediate grounds. So keeping this broad perspective in view, the BCIL have come out with an alternate source of protein for the aqua feed preparation and the manufacturing. So this is only one avenue of exploration. It may not immediately be acceptable. However, it's an initiative started by BCIL. Let's see and hear from the experts and also from the farming community and the feed manufacturers also. Earlier, we did have an option wherein Amba Shankar Garu has given an insight on preparation of low cost, low protein feed, if I'm not wrong. That is reducing the percentage of feed from 32 to 28, 26 for Vanamai culture. And we were actually concentrating and on the production. A lot of debate took place even on that day, and we did invite the experts from university and from the scientific community. At the same time, a few farmers have also joined us. So this is one such initiative to go ahead to know, because our aqua feed constitutes about 50 to 60% of the input cost, and fish meal happened to be the main source of protein for aqua feed. But in due course of time, fish meal to procure the quality and both procuring it had been a big challenge, and the price has also been a big challenge for that. There is also the other side of the preparation, not preparation. Other side of the issue is that there is a threat to the environment, and the scarcity and the depletion of certain species is also forecasted. So therefore, keeping in view all these aspects, the alternate source of protein for aqua feed preparation needs also to be explored. So it is at this juncture, because we know that for the protein source, we have been venturing all these days, and we found soya the best. Why soya is because the amino acid profile of Vanamai and soya almost matches, and that's how the experts across the globe have thought that soya could be a good source of protein for aqua feed preparation or manufacture. So therefore, at this juncture, genetically modified crops, its derivatives, and to be the immense source of protein could be one of the alternate source for all the feed manufacturers, feed people who are involved in feed preparation and feed formulation, and so on and so forth. So we are very glad that Dr. Vibaji from Biotech Consortium India Limited have come forward, and she had been working along, she had sought the assistance and the technical support from SEBA, Dr. Amba Shankar, who had been a good expert in the feed formulation, feed preparation and shrimp feed scope development. So both these eminent people today would give us a lot of insight whether we could take this concept forward in having an alternate source of protein for shrimp feed preparation. So, Madam, I invite you. Sir, Dr. Ambashankar Garu, I also warmly invite you. And we have all the, we have experts from university, retired professors, and we have, in due course of time, Dr. P. Krishna Garu, the former Commissioner of Fisheries and a good expert and a strong pillar of support to this aqua industry would also join, sir. I think presentations from both your ends would go initially, and after that we will give a lot of time and scope for the farmers and for the feed manufacturers how we can go about. And I think their inputs would really give us a lot of insight whether we could take this forward, because we have gone through different scientific papers and research that is done with reference to rearing the vanamai with this derivative or the protein source from GM crops. But however, to take on a commercial scale, would this sound better? Would this be befitting? Are some of the apprehensions that the farming community would definitely have, because till now it's going on one line, and whether this would really fit in, whether this would benefit, whether this would really give the anticipated production or not. So these are some of the apprehensions they have, and definitely this is not an overnight change or an overnight option, but certainly I think that would definitely inculcate, initiate, catalyze the understanding, and also the way to go about in times when we find there is a scarcity of this fish meal. Thank you so much, madam, for making us, that is the Department of Fisheries, also a part of your program. We invite you. I think first you would be presenting, or Dr. Ambashankar would be presenting. I would like to.
Dr. Ambashankar would present first, but I would like to say a few words.
Yeah, definitely. Go ahead. Go ahead.
Yeah.
Go ahead. Go ahead.
Thank you so much, Dr. Anjali, and thank you for providing this platform to interact with you and share this particular, information about very, very innovative and very, very successful, actually, alternative that is available for the feed manufacturers and the aqua farmers. So I would like to give a special thanks to Dr. Kannababu and to yourself, Krishna Maria sir, and Dr. Ambashankar, who is a great partner and has been, really supporting us in sharing this information. So warm welcome from BCIL to all the attendees, and just to give a very brief background, that this initiative is more like, as Dr. Anjali rightly said, a first step, a knowledge sharing webinar. And we are not expecting anything that you are going to immediately adopt, but just to understand what are these issues, and we would try our best to respond to your apprehensions and also take ideas from you on, what next should be done to, make use of this innovative technology. So thank you very much to everyone who has joined, and to the Department of Fisheries for once again giving us this opportunity. So
madam, if you would permit me, I have some other.
Sure, please.
Please. My senior colleague, DS Sudhakar, would be representing the Department of Fisheries and will moderate. Okay.
Right. Thank you so much. Yeah. So, sir, would you like to say something, or shall we move on to Dr. Ambashankar?
We can move on, madam.
Okay. So Dr. Ambashankar will be giving the first presentation. Over to you, sir. Doctor, I don't have to give any introduction about Dr. Ambashankar. He is much more familiar to all of you. Really an nutritional expert from the Central Institute of Brackish Water Aquaculture, who has been working in this area for a long time and has really the hold of the things. We are every day learning a lot from him in understanding this whole issues. And I am very hopeful that his presentation will be very useful. Over to you, sir. Thank you.
Yes, thank you, madam. And then again, very good morning to each one of you assembled here for this webinar. I think first at the outset, I should like to thank BCIL and Andhra Pradesh, because Andhra Pradesh Fisheries Department always there in the forefront. The country's 65% of the shrimp and fish production is done carried out by one single state. So we have to give considerable importance. There is the state is proactive, and once madam told we have to have some type of awareness, immediately we have planned it. Yes. Once their request has come from them, immediately we have to do. So this is how that genesis of that. So I again welcome everyone. I think without wasting much time, I will try to make an awareness or some form of introduction about this and what is the relevance of today's topic. Straight away, shall I go for my presentation, madam? Shall I?
You can share,
Yes,
sir.
yes, sir.
You can share. There is share screen at the bottom, sir. At the bottom, green color. Vinod, can you help, sir?
Sir, if you see at the bottom, the first icon is security and the second participant. Third one is the share screen. If you click on the share screen, I think you are mute, sir.
Yes. Now I will share that.
Yes.
Delhi. Another sir, Naradhan sir. Naradhan sir.
Sir, at the bottom one.
Yes, no, I said it 1 minute. The desktop it is there. I will try to share.
Okay, sir.
Yes, share screen for me. New share. Yes, desktop level.
You can see your desktop, sir. Yes.
Yes. Sir, could you able to see my full screen?
Yes, sir.
Yes, sir. We can see, sir. Please go ahead.
Yes.
Go ahead.
Okay, thank you. Then again, today's topic, first of all, welcome from my side and on behalf of ICRC also. So today's webinar topic on GM crops and the derivatives for aqua sector. So that my special topic will be the insignificance of plant-based proteins for aqua sector. I will try to, because under GM crops, what is the relevance of plant proteins, particularly for shrimp and fish feed, I will try to do that. If you look at that, I think most of the participants, they know I need not give much of introduction about this, what is the necessity. But anyway, I will tell about the significance of aquaculture. What is the importance of our particularly shrimp and fish, then our Indian aquaculture scenario, what are all the ingredients. So here, what is the most important role of plant protein? So that all we will understand where we have to go forward. Then what are the research strategies, and then alternate proteins, and then what is the modern research tools available. With that, this is how I have organized my lecture. So all you can go through that. So when or at the end of the lecture, we can discuss. So this particular slide I wanted to emphasize that the food supply, we have to double by 2050 to feed the 9 billion population. So in that, the production from the terrestrial side is limited. So everybody is looking for ocean. So in the ocean, rather aquaculture. And particularly aquaculture, in the constraint of climate change, other thing, increased scarce resource of fresh water, this brackish water aquaculture will continue to increase. And moreover, fish also contribute 17% of the global. So here, what I wanted to this one, already we know food from aquaculture is good, healthy, safety, and then it is taking care of not only the food security, it is also taking the nutritional security. That means the demand will continue to increase. So for the burgeoning population, we can meet the food security as well as the nutritional security. then aquaculture is the only option. And particularly why our foods are relevant. See, I have simply compared the nutritional richness of our food. If you compare the shrimp and fish when compared to all other known non-vegetarian, it is the highest protein containing food with the lowest possible lipid. So that is the biggest advantage. The protein is highly balanced and amino acids with low lipid. And whatever even lipid is there, it is highly beneficial. So in that context, now everybody will aware that food from aquaculture origin is safety and good for human being. So the demand will continue to increase. Already the concept is being getting up, and there is a clear-cut difference in the younger population for preference towards the fish and shrimp. That means the demand will continue to increase. So aquaculture will continue to increase. So feed demand will continue to increase. Again, further, if you look at that, the human health point of view, if you look at the saturated fatty acids, our shrimp is the lowest. And then cholesterol, even though it is moderate, it is not harmful. And then the atherogenic index also better. So all the health indicators also very clearly point, there is a clear-cut advantage. These are the driving forces, driving factors which will drive that this demand for food from shrimp, particularly aquaculture, shrimp and fish will continue to increase. That means we have to have a plan how to make it sustainable for the increased demand. And in the context of climate change also, among all the known species, our species are the highly efficient, particularly the lower greenhouse gas emission when compared to other terrestrial animals. That means in future, these are all the future sector, it will continue to grow. That means that we have to think, we have to strategically plan how to make it sustainable, because all are advantages, nutritional richness, environmental friendly. Also in this context, we have to plan for that. So in India, all we know, there are principal freshwater fish species. Then these are the diversified species. Then for catfish, another thing. So, but these three species I want to take because these are all the under formulated feed under freshwater, this Pangasius, tilapia, and Rupchan. So these three are highly amenable for extruded feeds. So the feed real quantum of extruded feed started increasing only for these species. If you come to the brackish water aquaculture, so shrimp farming is the phase of the brackish water aquaculture, and most of the kind of 42,000 crores annually we could able to earn. Even it has beaten basmati rice. So that has got the potential, and we are also trying diversified species, particularly sea bass, mullet, and milkfish and pearl spot. So if you look at that, particularly marine shrimp and fish species, it requires marine protein ingredients are the mainstay, particularly fish meal. So fish meal is the main thing because the amino acid profile is highly balanced, and then it is required what is for the good growth of the shrimp and the marine fishes. So that, but what is that? It is costly, and then availability, and these are all the factors. But how we can target? There are n number of other alternate byproducts from the marine product, like a good quality dry fish waste from them, then javala, then prawn gut waste, skulla, squid waste. So these combination of ingredients will also sustain to certain extent. So not only depending upon the exclusively source from the fish meal. So if you look at that, this is an organized fish meal. So fish meal is the main ingredient, and then a quality steam style fish meal is very much for a species like shrimp and marine fin fishes. So if you look at the fish meal and fish feed production in India, so fish meal production in India and globally also fluctuates, and almost it started showing a plateau. If you look at that, globally 5 to 6 million tons of fish meal only produced for the last 2 decades or so. But whereas our aquaculture started increasing. So what is the way out? One side we are telling aquaculture continues to increase, rather the main ingredient started stagnating. That means we have to find an alternative. No longer we can continue to depend only on the fish meal. So if you look at that Indian scenario, almost 4 lakh tons of fish meal is produced. 2.5 lakh tons is domestically consumption, around 1.5 lakh we are exporting also. But in addition to that, 30,000 tons we are importing also. But considering the sustainability, a good quantum of around 1 lakh tons of fish meal from the byproduct also in India is producing. This is the statistics to know how we are changing. So recently this byproduct fish meal started coming. These are all the alternative ways how we can sustain. There are many strategies to sustain our aqua feed production and the aquaculture. In having this, so even in India also, but recently also many of the feed millers are there. Now availability of the consistent availability of the fish meal is the question, because it depends upon the catch. Even recently the fish catch was not there. So the fish meal production started showing a plateau or a decrease. So in this context, on the other hand, our aquaculture started increasing and then growing. The feed requirement started growing. So if you look at the shrimp feed use, from after introduction of Banami in 2009-10, we have introduced Banami. So from 2 lakh metric tons, it has gone to 1.4 million metric tons. You see the growth. Similarly, a equal quantum of fish feed also produced from the, so during this year. So this will continue to grow. Even our ambitious target of doubling the fish by another fish production in the country by another 5 years. That means we have to double the fish feed production also. So then what are all the options available? What are the ingredients available? So now it is very clear, feed from the marine sector or ingredients from the marine sector, it is a limited. So even the limited, we have to try different sources. But what other sources means, only way is go for a plant protein. So in the plant protein, everybody know that 50 to 60% is the plant protein cost. So feed cost is meant. So we have to try alternative ingredients. So why we cannot use so much of plant protein? What is the real? So if you look at the India, no doubt, even shrimp feed, soya is the main ingredient, which is highly amenable. So starting from now, people started using as high as 35 to 40% soya. So if you look at that, soya is the single most highest ingredient inclusion level it is being used. So in India, there are two types of soybean available, Hypro, which is very good for shrimp feed, and then other ordinary soya. So both the soyas are available. Then in India's agrarian country, we are having a number of oil seeds, and then considerable quantity of all other plant proteins like cotton seed, groundnut cake, sesame cake, rapeseed or mustard, sunflower cake, copra cake, DDGS. So these type of n number of plant proteins are available. So how to make use of that for to increase it? So I see a great scope. So a combination of different ingredients with a combination of different strategies, we can make it sustainable. So and even other byproducts like a black gram bran, green gram bran, these ingredients are not utilized, but it has got some inherent limitations. But there are scientific research or methods of amelioration is available, so we can able to include these. So if you look at that plant protein, so what is the main potential alternatives of plant protein? So here, if you look at that, it is locally available. Limitation is the palatability, anti-nutritional factor, protease, fiber, NSP, phytic acid, tannin. So we have to remove that. These are all the main impediment. So inclusion of plant-rich disease. So how to avoid that? So main thing, we have to enhance the palatability, we have to improve the digestion, reduce the anti-nutritional factor, reduce the phytate, and then whatever amino acid balance is there, we have to properly balance with supplementation of extraction or combination of ingredients. These are all the strategies through which we can use all other plant proteins to make it sustainable. So here in this context, we worked on enzymes, no doubt. Enzymes, we can add application of enzyme either on the raw material or to increase the animal performance. These enzymes are substrate specific. Each plant protein has certain specific substrate. So we have developed a customized enzyme mixture that we can use, and then the inclusion level of the plant protein can be further increased by supplementation of the enzymes. So here we have to see that so enzymes are not substrate specific, and the random use of enzymes without consideration of substrate will not give desired results. So here we have to give for the activity, stability, shelf-life of the enzymes. So these are some challenges that already some research solutions are there. We have to use that. So why we have to go enzymes? See, fiber and NSP. This is a cage effect, means even though nutrients are there, if the NSP and fiber is there, it will not allow the nutrient to be released. For example, a simple digestive like shrimp. Within the 40 minutes, the feed has to be digested. That means, so that is why our fiber requirement in the shrimp diet should be always less than 3%. If more fiber, it cannot be digestible. So the fiber not only digestible, it will also make other nutrients unavailable. So in this context, we have to use both fiber degrading enzyme as well as NSP enzymes. So for each enzyme, even including soybean meal, rapeseed meal, each we have find out what type of enzyme, what is the combination we have used, and then we have made some. So from ordinary level, almost 25 to 40% increase in plant protein can be done through proper selection of a substrate specific enzymes. We could be able to improve that. This we have done it. And then we could be able to demonstrate that through use of substrate specific enzyme, we can increase the plant protein sources. Then one more anti-nutritional factor is the phytic acid. I think among all this is the main thing. So phytase enzymes has come. So through this also we can further improve. So phytic acid, it's not only phosphorus, it also make other nutrients also unavailable. So once we release the phytic acid, the nutrients will be released and it will be useful for the animal. So these two enzymes got a major role. So this industry has to think forward how to make use of that. So these are all the different enzyme application. So here, but why? Even though research has done, we could not be able to gain much in use of application of enzyme. We go to see the challenges also. The consistency and the predictable gain is always sometimes me, because the enzymes are substrate specific. So much of complexity is there, both in the nature of the substrate as well as the enzyme. So that is why consistently it has failed to give a consistent good performance. But now recently there are a lot of the improvement in the biotechnology and this one. we could able to get good quality enzymes, and the stability has also been increased. And then we could able to understand the exact complex nature of the substrate. Then based on the substrate, if we could able to supplement it, then if we treat it properly, then we can be able to increase the plant protein. Then again, you look at rapeseed meal. This is one ingredient, equivalent variety, genetically modified, not genetically modified. Through genetics, conventional genetics type, people who improved that, low glucosinolate, low erucic acid variety, particularly called canola. This canola meal is being extensively used in the USA and other Western countries, whereas our own variant of our Indian rapeseed, we could not able to use it. Recently, we have analyzed why we could not, when others are using very rich advantage of rapeseed meal, we found out that mainly the glucosinolate and erucic acid are made. But recently, due to the oil extraction process, even the erucic acid contents have come below down. Now, the only problem is the phytic acid and glucosinolate. So if we find a mechanism to reduce the phytic acid after preparation through proper processing, or through genetically, whether we can be able to reduce the phytic acid or the glucosinolate, we can substantially. So these are all the research opportunities already with all plant breeders. So now it is a time, both aquaculture people, agriculture people, plant breeders, end user, everybody, we have to work together. So I think this rapeseed meal is one good ingredient. Now presently, what is available, we can detoxify or process through some form of treatment like pelletizer. I mean, these are the different methods are available. We can try to use the inclusion of rapeseed meal in stream. These are the research opportunities. So the glucosinolate we have found out. You see the German variety, 00 variety, where the glucosinolate content was less than almost 50, the recommended level for as per the European Union standards less than 20 micromole, whereas all our varieties contain more than 40, 50. So this is the factor. This only causes the decrease in palatability and then availability of the nutrition. So through genetic mechanism or any other proper like biofermentation methods by using thermatic like micronizing technology, infrared, hot air expander, or even we have found out that simple pelleting and extrusion of this rapeseed meal could be able to reduce the glucosinolate by 30 to 40%. So the rapeseed meal as such, if you can pellet it or extrude it, and then we can use the inclusion level maybe increase up to 5 to 6.7%. So these are all the different avenues. Then more recently, solid state fermentation also is used to give you a better removal of all these glucosinolate and other antinutritional factors. So these are all the avenues. I think all the food industry has to come forward. We have to work together, and then we go to include the increased level of plant protein in aqua diet. So this is the solid state fermentation. So any ingredient through proper either source enzyme from the bacteria or fungi. This is the solid state pilot scale fermenter. Recently now we got some improvement in the inclusion of plant protein after the ingredient has been substituted for solid fermentation. We could able to clearly increase that. So these are all the strategies. But again, we have to optimize the cost and processing condition. So now any fermentation requires a little bit higher moisture. That only we got to work it out how to solve it, how to economically optimize that. So these, I think industry has to come forward. We get research institution, industry, and everybody, we got to work together to find a way for sustainability and then increase the plant protein sources. Then as an our lot of interest has been created for biofloc. So in the biofloc also, yes, even if you reduce the fish meal, so a little bit of biofloc, if we meal, we can include. So these are all the research opportunities. Future, it will find a way. We include that, then reduced fish meal can be used. So more of plant protein can, because it contains specific nutrients. So that is what we could able to find out. Then as a byproduct, so even see a lot of the domestic fish waste is simply, nobody knows the nutritive value. It is as good as a fish meal, but only thing almost 30 to 40% is being discarded as a waste after during the processing for human food consumption. So if the waste, if you properly collect and use, so this can also be used as a one of the byproduct fish meal or as an algae ingredient. So we have made into both as a hydrolysis as well as the both presently we are. It is a very rich in amino acid profile. So these are all the opportunities to make sustainable. So even 20% is included, even at least 10%. Then for a fish meal replacement, it will work hard. So it's coming to the today's context of what is the GM crop-based ingredients in animal feed. So mainly, what are the ingredients? If you look at that, corn, soybean meal, canola, and cottonseed meal are the major GM crops throughout worldwide. It is being used. In India, all we know that our BT cotton way back in 2002 introduced. and it has also been used. Even the cotton seed oil also we started using that. So there is no harm and there is no side effect or anything, because already it is being there in the food chain directly to the human. So there is no point in for recently in the last, due to the increased soya price, government also allowed. And recently this ICR recently also rapeseed meal also have been introduced. So at present in India, both cotton seed meal and rapeseed meal, it can be this one. And recently we started using the GM soya also as a own consignment. So GM crops to meet the requirement of, so here in GM crops, again, we have to target. So even during the genetic selection, we can target the specific nutrients in the ingredient, decrease the anti-nutritional factors, intervention in the nutritional pathways of animals. So if you look at that GM crops introduction, actually in 1994 globally, it has been commercialized. From that time onwards, most of the countries took advantage of that, and then they could be able to get a better yield. So so far the existing research information revealed that the GM crops could be able to reduce the chemical fertilizer by 30. So this is a one review by our plant NDPGR director. Recently it has come in the paper. It could be able to reduce the chemical fertilizer by 37% and yield by increase by 22%, and then farmers profit by 68%. There is no harm. So these are all the advantages. These messages to go. So now no other way. Now we are in a way because this type of advantages we have to also, even developing countries like even Bangladesh, Bhutan or Kenya, these people also started now using the GM crops for food and human beings. So currently, if you look at that, 29 countries cultivate the GM crops and then 43 countries import. So these are taking advantages. So we should also lag behind in getting the advantages. So the safety of the GM crops through scientific study has been proved beyond doubt. So no problem. So even our own case in India, see, cotton seed meal is a good thing. Even our own, cotton seed oil is extensively used in the human diet also. So there is no fear for this one. So what is the safety? Why people, what is the concern people are writing? Whether could genes transfer to animals and its effects on animal product. So far, so much of plant protein we are taking, there not even single list any plant gene has been detected in human. So anyway, everything will be digested. So these are all the myths we will not affect. So existing clear scientific studies reveal no detrimental effect to the animal fed with GM crops. And even if it is there, you look at what is the amount of GM content in the food crop. If you look at that, it is very, very low, insignificant. Even the insignificant amount, once the DNA will be degraded, there is no chance of jumping up the genes or any foreign material entered into the system. But even then, always, even your strict committee is there, even ICR, for introduction, all these things they will see, and then we will do that. So biosafety risk associated with it. So even for Aqua also, we can exclusively feed on this GM soya, and then we can study what is happening, whether we could be able to detect any type of this foreign genes in the finished animal. So these are all the research. I think industry we can sell together. So that will help. So all without any fear, we can continue to take the advantage of the scientific this one for this our future crop on this one. So to summarize, plant proteins are the more sustainable and consistent in quality. So these biotechnological and engineering tools are available to manage the anti-nutritional factors and to increase the specific functional nutrients. So research focus on nutrigenomics, nutritional programming, GM crop-based ingredients and functional ingredients without affecting food safety. This we have to start immediately. So what finally I will try to say that a multi-pronged approach is essential for the salmon. So we have to attempt different approaches. In the marine, alternate ingredients, different approaches, increasing the efficiency, use of plant proteins, use of different techniques, use of enzymes, then use of GM crops. So all definitely, if you adapt, each one will contribute. And then finally, we will make it is sustainable. So what is the way forward? So my take-home lesson is the modern scientific research with record regulations is the need of the hour for food and nutrition security. Necessity for minimizing the environmental footprints of aquaculture, along with the enhanced climate resilience and a desired nutrient flow. With this, I will thank, then I will end with our institute slogan of brackish water aquaculture for food prosperity and employment. I think I could be able to highlight some of the important points, maybe during the discussion to all the members, I can able to interact and then better. So this is only that awareness meeting. So then we will discuss further. Thank you. Thank you for the opportunity. Thanks one and all.
Thank you so much, Dr. Ambashankar, for giving a preamble on all these plant-based proteins. What I will do, if you can take off your presentation, then I'll share this. I will quickly give 15 minutes, maybe very quick overview of GM crops, and then we will open it up for discussion. Sir.
Okay, that's fine.
Right. Just. So the slide is visible, sir? Anybody can confirm the slides are visible?
Yeah, it's visible, ma'am.
Okay, in the slideshow mode, no? Okay, thank you. So, Dr. Ambashankar has mentioned that plant proteins are the need of the hour for the feed manufacturers, and it is the biotechnological interventions such as the genetically modified crops which can actually support the requirements of the GM crops and derivatives for animal feed. So what we will do is we will quickly try to understand what exactly are these GM crops and what are their issues with, and what has been the global experience of using this and how they are, successfully being used by others. But before I start, I would like to very quickly mention about our organization, which is the Biotech Consortium India Limited. Maybe many of you are not aware of it. This is a company which was conceived by the Department of Biotechnology, Ministry of Science and Technology, for accelerating the commercialization of biotechnology and provide linkages between the government, industry, academia to take forward these modern biotechnologies to the benefit of the society, the farmers and the consumers. So we are a public limited company, and we are actually a consortium where the government is in advisory capacity. The research bodies like ICR, CSIR, all are in our own, the representatives are on our board. ICMR, DBT, DST and all. And then we have development banks as our financial institutions. And finally, the token participation by the industry, for giving us this commercialization based inputs. We work in a lot of areas, technology transfer, IP management, project management, and regulatory support services. And then, things like communication and outreach, like the one we are having now, for the genetically modified crops and interactions, consultations, interactions, and providing information with the all stakeholders. We provide platforms for bringing together various stakeholders also. Dr. Ambashankar mentioned about the genetically modified crops, and we keep hearing about them, both plus and minus about them. So I thought it would be nice to first know what exactly these are and how they are different from what are what we call as non-GM crops. So GM crops are the one where the genetic material has been altered using genetic engineering. That's a modern biotechnology. They are also referred to as genetically engineered crops or transgenic crops, or sometimes the living modified organisms. You see, it is not that genetic modification is possible only with modern biotechnology. Even our new crops that we use, the present day crops of tomato, corn, soybean and all, they were not like the ones which were in wild. So there is a plant breeding which happens by the plant breeders to improve these crops on a constant basis. And how they do it is that they try to understand a desired character, a desired gene, and which is then crossed with a commercial variety. And then we get this desired trait in the new crop. However, this is done in the field by crossing the related, species. The corn species A, corn species B, tomato A, tomato B. So like that, those which can cross in nature. However, genetic engineering is one technology where we could take a gene using a modern technology in a very precise manner. And all this has happened because of the advances in science and technology, by which we could read this genetic, setup in any organism. The genomics is a science, it's called genomics. And now we know in many crops or even in animals, slowly the understanding is getting improved, which gene is for which trait. So once we know that, we in the laboratory, we can actually take this gene and put it in the commercial plant variety. No, till this, it is perfectly fine. We were doing it by, field research, which took a lot of time, because along with one, many other genes also got transferred. Here we could do it with much more precision. But there was one more thing which happened with genetic modified crops, that now we don't need to worry about genetically modification to happen only between the closely related species. We can actually take these genes from any other sources also, like bacteria, virus, fungi, animals, whatever we want. So because of that, This was a very big breakthrough. A novel products could come. However, there were also some concerns that if you are taking these genes from other organisms, so we should do some kind of a safety analysis before we start using it. I will give you an example. There is one crop called BT cotton, extensively used in, grown in Andhra Pradesh and Telangana. So this is an insect resistant GM crop. Now the gene for the insect resistance has come from a bacteria which is present in the soil. So this gene is taken and it has been added into cotton, corn, brinjal, number of organisms, and this gene produces a protein which is toxic to these borers, but it has no other impact on any other, organisms, and provides a built-in defense. And that is how this BT insect-resistant GM crops have come. But this would not have been possible with plant breeding, and hence this use of modern technology called genetic modification has come. So as Dr. Ambashankar already mentioned that globally there has been extensive usage, from 1.7 million hectares to almost we have reached to what you say 190 million or almost maybe touching 200 million hectares globally. And whichever country these crops were adopted, it is almost 95% adoption. So in India, when BT cotton was approved, 90%, more than 90% adoption. So this is just a glimpse of, so you can see the North America and the South America and all these agriculture countries where most agriculture is more prominent. Those are the ones which have adopted these crops. And there are many other countries which are smaller ones like Japan, South Korea, Philippines, all Mexico. These are the importers, but they also buy a large amount of, what is this GM crops and do not cultivate it, but they use it for food and feed purposes extensively. So as you can see that there's a lot of experience in the global level for using it for multiple purposes, for poultry, for aqua, for animal feed, even for food purposes, their byproducts are used. For example, BT cotton, when it was approved, it tripled our cotton production because we could fight that insect. And in addition to that, if you see this text in red, it is the cotton seed was produced. Cotton seed also came in higher amounts. And this byproducts, that is the oil and the meal, that also tripled. And that is how the feed industry was also greatly benefited because they got 3 times higher cotton seed meal for use. So as sir already mentioned, soybean meal, canola meal, cotton seed meal, and there is another product called dried distillers grain soluble, which is called DDGS. That comes from corn, distillation of corn for ethanol production, and it is a co-product of that. These are the 4 very important products which are being used in livestock feed extensively, and none of them contains any living modified organisms. And that is why most countries are freely trading this product. Like in India exports cotton seed meal, we produce it from BT cotton, we don't need any approvals. But in other countries, or similarly, many other countries are also, permitting it free transport of free trade of these organisms. Soybean meal, I won't go too much into detail because we want to give you more time for discussion. So soybean meal is a byproduct of the extraction of soybean meal. And at the global level, 98% of this soybean meal is used as animal feed. And in whichever country, almost 80% of the total soybean grown at the global level is genetically modified soybean. And because of that, when India had to import soybean meal, it is very difficult to get non-GM soybean meal anywhere in the world. You mostly have to, you will always get a GM soybean meal, which has been proven to be safe. It has been for many, many years. It's been almost 20 years that this product is being grown and traded globally. DDGS, I already mentioned, this is also used in many countries for animal feed. In fact, since you all are from the aqua sector, we had some time back a webinar on DDGS, and we heard one international speaker talk about some international studies and how DDGS is being used for aqua sector. So this is just one research paper in which they showed that in a 2-stage trial, corn DDGS was shown to be used up to 15% as an alternative ingredient in shrimp diet. And the diet costs also showed that your feed prices can actually be reduced if you use corn DDGS. I am writing this corn DDGS because corn DDGS can be derived from multiple sources. The most common being corn and rice. In our country, it is mostly rice. So corn is in the, when you import or when you are globally, corn DDGS is very popular. Since this study is from outside India, the results are from the corn DDGS. Cotton seed meal, I have already explained you that it is a protein-rich feed and extensively used. Now come the question, that everything looks very nice, that it is grown, it is similar and so on. But still there is some debate about these crops. Very often in the popular press, we see some people say, like sir mentioned, biodiversity loss and this and that. Because of crops also, this kind of issues come up. So I just want to share with you that the genes, since they are from various organisms, as I mentioned, from bacteria, from various fungi or any other organisms, or maybe different classes of plants. So there has been this safety concerns raised by the scientists, even at the beginning of when the technology was made. And in the pharma sector, we have several products which are approved, and the first one was, of course, the insulin. 100% insulin in India, at the global level, is all from bacteria through modern biotechnology, through genetically modified organisms. Similarly, most of our drugs, similarly, all this COVID vaccine shot that we took, everything is through this technology, and there are very, very well established, procedures available and which are used. So for scientific concerns in crops and foods, several international organizations like Codex Alimentarius, CBD, OECD, they have come out with a lot of methodologies. I'm not going to discuss all those methodologies here with you. Of course, Dr. Ambashankar did not mention, but I would like to share with you that we are going to have a detailed in-person workshop also at SIBA in this month only, on 25th July. So I invite all of you to come there and maybe have a more detailed understanding. So safety assessment, when we do the GM crop, is through food safety assessment and the environmental. Every factor, right from what is the source of the gene, what is the protein, what is the compositional analysis, which is so important to you, and environmental issues are all studied in detail. There are, dossiers made of thousands of pages, which are submitted to the reviewers in every country and wherever it is to be commercialized. So India also has a regulatory system led by the Ministry of Environment, Forest and Climate Change and the DBT. There are various committees, I'm not going to name them all. There are various committees which look at it right from institutional level to the science review and the field testing and so on and so forth, which is done in this detail. And just to summarize that, evaluation is by the scientific bodies as well as regulatory agencies. It has been 1996, almost, more than 25 years that these crops were first commercialized. So there are several scientific bodies like National Academy of Sciences, World Health Organization, FAO, American Medical Association, Royal Society of Medicine, and our own science academies have reviewed and said that, these are the crops which are a very good alternative and they should be extensively promoted and used and made benefit of. Agriculture has a lot of challenges. While you all are growing, the agriculture has to commensurate to that growth, and provide you with the feed. Only then, our the livestock sector can grow. So just to summarize, what I wanted to share with you was that GM crops are commercially cultivated and traded across the world. Number of crops and area is steadily increased since the introduction of first crop. And now in the recent years, we have seen, like sir mentioned, Bangladesh approved one crop based on our data actually. And then African countries are also now coming forward and, adopting these crops in a big way. Almost more than 70 countries, this number keeps increasing all the time. Products from cotton we already have in use, and the mustard is now in the varietal testing. It has been approved by the GAC in the varietal testing and will be available. Systematic regulations are in place. And just to talk about what sir said about the canola seed meal, similar research is also underway in India. But what we need is that, we need extensive research and field testing. We need support from the user segment so that researchers can take forward their products and then make it available for use by all of you. So plant-based proteins are derived from GM crops, extensively used. They provide a very attractive option for aqua industry, particularly things like soybean meal and the DDGS need for extensive research in India. And there is a very urgent attention. And you know, one more thing is that, as I mentioned, many of them are non-LMOs, you know, so they are not living. So they are just products which have already been tested. So we need a very clear-cut system for the permission for the cultivation, import, and use in the country. Presently, the system is there, but more clarity required from the feed point of view. From the feed point of view, there are definitely not very clear, pathways available. So very urgent attention required for exploring the use of these crops, for meeting the requirements for all of you. We have prepared one brochure by name of FAQs on GM crops and animal nutrition. So I will share it with Dr. Anjali and the Joint Director, sir, and maybe we can circulate that to you for knowing more about these crops. And if you have any questions, please feel free to connect with us, and we will be very happy to respond to your queries and see how we all can work together to taking forward the use of this crop for your benefit, for the benefit of the aqua feed manufacturers. Thank you so much.
Ma'am, you are mute.
Sorry. So may I request the Joint Director, sir, from the department of to kindly take it forward and moderate the discussion. Yes, sir, please. Over to you.
Actually, the presentations are related to aqua feed manufacturers. So the research wing, there is no research wing in our department. So we need to take information from you and the Shiva. So this is time to manufacturers and entrepreneurs like Mohan Raj sir. Okay, thank you.
Thank you, sir. And if any of you have any doubts about any questions or concerns or any further discussion points, you can talk now, and Dr. Amba Shankar and myself would like to address it now, or we can get back to you, or we can engage ourselves in discussion. And I don't know, Dr. Krishnamaya sir is here, or has he joined?
Ma'am, can I start?
Yes, please. Yes, please.
Good afternoon.
Introduce yourself also.
Yeah. Good afternoon, ma'am. This is Mohan Raju, Prawn Farmers Federation of India.
Okay.
Good afternoon to you and Dr. Amba Shankar and Dr. Anjali and her team and other participants. There are a few questions to Dr. Amba Shankar. Dr. Amba Shankar ji, that's, we have got some doubts about, that canola mustard, that 00 mustard.
Yes.
Can SEBI has worked anything about it regarding 00 mustard, which was proven in poultry and dairy?
Yes.
Because it's not even, it's not a genetically modified, it's a modified this thing.
Conventional, yes.
Yeah. Because, mustard since last 30 years we are using in fish in Indian major crops.
Yes.
But, we used to face, some digestive problem, those things. But now, from Dr. Vijay Sadanand videos and other information from the poultry end and dairy end,
Yes.
I hope it's given very good result. Is almost better than the soya meal. I hope you can throw some more elaboration on that 00 mustard.
Sir, thank you, sir. Actually, this is we also thought why could not. So only recently we have initiated. We collected some 6 varieties of Indian mustard, and then we imported one German sample of 00 variety. And then we found that most of the nutrients, only the problem is our Indian variety is, previously we thought erucic acid is the main thing. Now erucic acid problem is not at all there, because oil extraction is so high, almost during solvent extraction, most of the erucic acid and the variety also considerable improvement has gone. The present variety erucic acid content also low. And whatever content is there, so erucic acid is not a problem. Finally, we have found out that the two major problems are glucosinolate and then phytic acid. So these are all the two problems. So these glucosinolate and phytic acid, how at present, how to remove that or reduce that. So the existing research information says that such type of even thermal cooking thermal processing, it has got a little bit reduction. We have found out some studies experiment on through pelleting and extrusion, some 30 to 40% reduction is there. Along with this, through conventional genetic selection, we can able to reduce the, because these two factors causes decreased in problem in this Indian mustard is the highly pungent, and then palatability is affected and digestibility affected. So if we reduce this glucosinolate and then phytic acid, I hope we can make an alternative ingredient. I think even the present ingredients through process amelioration technique, we can work and then we can jointly demonstrate that, so that it will be a good to the industry and it will make sustainable way forward. This is my initial comment, sir.
Sir, just to add to what you said, sir, canola seed meal that we get outside, that is all genetically modified.
Yes.
And that is something which has low glucosinolates also.
Yes. Yes.
But we have been there is some research going on here also in India, and there is one institute which has developed a genetically gene-edited mustard. They will be shortly coming out, and they have 0 glucosinolate and 0 erucic acid. But the thing is, sir, it is not just related to one of these problems. Of course, we have to see the amount also, is also an issue. The amount of availability and the prices.
Yeah,
so
yeah.
that's why we have to really look at these options.
Ma'am, because the huge demand is there,
Yes.
Yes.
particularly that, aquaculture sector or poultry sector, which, as a end product, end user, we are unable to bear the prices of the soya meal.
Yes.
Yeah, now, that farmers in Haryana, Punjab, they are suffering with, over wheat production. Those areas, we can promote, means what exactly the 10,000 acres which is promoted by the poultry people in Punjab, and they are getting the 0-0 mustard from there, and the results, they are quite happy with that result. Even, they claims, in Nestle, the 0-0 mustard replaced with soya meal, it has almost, yield was improved by half liter and the fat was improved by 0.1% or 2% like that. It's a Nestle's R&D paper. Means that's why I'm asking doctor from SIBA, because already, they are in the feed division also. I hope they can start, some primary work on that.
Yes,
Yeah,
sir.
very right, sir. But what I wanted to share with you was that, transferring the area from one crop to another is definitely a need-based thing which has to happen. But we will not be able to get, meet our productivities unless we go for the modern technologies like genetic engineering or gene editing. The way, these foreign countries have gone, and they are able to get such high productivities. So there, when we talk about that, we also need support from user segments like you all, which can say that, yeah, we are open to, because if globally everyone is using these products, so we are also open to using these genetically modified ingredients. So if that kind of, clarity is there from interaction between both the user segments and the producers, then this will give a boost to this kind of research, and also, maybe imports in the short run or whatever, to check the prices. All options have to be looked at. So basically, the reason why we wanted to share this with you was that we have to look at multiple options, and we have to be open to use of these crops, and in fact ask for that. There should be an increased productivity also, which can only come from area will keep on getting reduced, sir. Today you may divert, tomorrow another crop will come, and there are numerous other activities, and the agricultural land is going to be reduced in future.
Yeah, but regarding agriculture, ma'am, we are excess production. We have got now, almost 5 to 10 years inventory is there.
Yeah.
Now, why to worry about that? Because at the same time, we have to see that not only that means we have to look for the animal protein also, for the
Animal protein, yes.
for the working group, and because the youth is our big this thing for us, for our country.
Yes.
Age group of 20 to 35 years age group, they are almost more than 40%. The age group is there for them to take care of their protein resource. We have to look into it,
Yes.
ma'am.
100% agree, sir.
Yeah, ma'am.
Yes.
There are two more for both of you regarding DDGS, both your presentation and Dr. Shankar's presentation. Preferably, you are saying the maize, but the maize will have the fiber. Why particularly shrimp feeds? Why the people are opting high pro soya is just they're removing the shell and they're going for high pro. Is between the soya meal and high pro soya, no difference except the shell. When you are suggesting maize DDGS, definitely maize will have the more fiber than the rice or wheat DDGS. Can you focus both of you about that? Some clarification about that regarding maize DDGS and rice or oblique wheat DDGS?
Yeah, from my side, Dr. Ambashankar will clarify more. From my side, I just wanted to share with you that I'm not recommending anything like corn DDGS. The only thing I was trying to say was that because internationally, corn is the one which has been used for fuel production in US particularly, and they are the ones who are selling very high quality DDGS across the world. And because of that, the studies which are available that we come across were mostly related to the corn DDGS. So over to you, sir, on the preference of whichever. I think some studies would need to be done.
Actually, recently speaking, that the real fiber content will not be much difference between the rice DDGS and maize DDGS, sir. If you look at that, the actual concept after concentrating, the proportionate increase will be fiber will be there. Even as such, in the whole cereal of maize, the fiber content will be less only. So we need not bother. Even the most of the finished products of even maize DDGS, the fiber content is less than 5 only. Whatever the sample it is, that may not be a much issue. Only thing what we have to concern about the if at all if we have to screen for toxins regarding maize DDGS. Otherwise, even rice DDGS, anything by analysis, what we have found that it's not, we need not worry about the fiber content much because it is not this.
Much. And regarding
one more thing, one more point. Your previous question, I wanted to clarify. You raised a very relevant point. Yes, I also personally hope there is a lot of opportunity and potential in the rapeseed meal. Even though the genetic it will come, even like industry people, we can join with them and then we can straight away. And even I do feel that whatever Indian rapeseed currently available through certain processing or ameliorating technique, we can include it to 5 to 6%. That if we can, industry can come forward, we can work together, sir. We are always open. We will try to solve that. So that is one approach. The other approaches, as Madam told, nothing like a genetically modified. This one, it will come. At present, immediately what is available, we can try to improve. Then now recently we started working on different amelioration technique. What is the best technique that we can incorporate and try to include at particular level so that it can be included in the shrimp field. Like that we can work, sir. We are open.
Yeah. Dr. Ambashankar, one more this thing.
Yes.
Regarding bioflak.
Yes.
Means you want to raceway bioflak and collect the bioflak and use in the feed.
Yes,
otherwise,
yes. This is the research information, sir. What we have found out that whatever bioflak we could be able to, even if we include one particular percentage, fish meal we can able to reduce that because certain nutrients what is present that is taking care. But for this technology has to develop, the large quantum of flak has to produce. At present, it may not be cost-wise economical, but these are all the research leads. So in future, there is a way, if we can do that, even if it includes 1%, there is always possibilities that your fish meal level can be reduced. That is the information I got.
Yeah, exactly. Yeah, lab scale, speaking the lab scale is okay, but commercial scale, yeah, you're right.
This avenues, I hope, even at one particular ingredient, even if you reduce by 2% of fish meal by including even 0.5%, that is a good thing. This is what a multi-pronged approach with different strategies. So those who are amenable for this we can, because what we have found out that improved immunity of the shrimp is increased using the biofloc meal. PHA, polyhydroxybutane, one compound is there. This compound is improved health and other things. These are all the preliminary information. But once it has come to the upscaling and commercial level, I think these are all strategies. I am just highlighting.
Yeah. Ambashankar, the last question for you.
Yes.
Because as a prawn farmer, we are looking for alternative species since last 10 years, and
Yes.
we used to do the sea bass and other marine species. And in freshwater area, we are doing major carp or funguses or bass, this thing, paku. Yeah, paku. And regarding the low protein, these things like IMC, paku, funguses, whatever you said, this already we are using in the DDGS and all those things already. But when it will come for the sea bass and groupers and other marine fin fishes, we are not happy with our Indian the feeds even. Means we are totally dependent on either trash fish, otherwise imported feed. The CBI has worked anything about these marine fin fishes to replace this fish meal, this thing? Anything? Can you throw
I think
some
again you
points?
asked a very relevant question. Actually, among all the marine fin fishes, it is a little bit different. You cannot compare it with either freshwater fish or this one, and particularly sea bass. It is a predatory carnivore. In the nature, it will attack the other fish and then take it. And then fish meal level inclusion has to be high. So we found a reasonable inclusion, but any marine fin fish, considerable amount of fish meal and fish oil has to be there, sir. But we have also got exclusively feed for sea bass. We could able to use an array of combinations of ingredients, not to that extent, a little bit quantity we can use, and then we can try to reduce the fish meal. So these type of certain ingredients are amenable that we can use that. Not again, the problem is that again palatability, fiber level. Even in sea bass, the fiber level should not go more than 4% in the finished feed. So in that context, our conventional plant protein we cannot use. So those plant proteins which are very good, that is why again in sea bass, again the soya is the main thing. Other thing we could able to find a little bit like your DDGS or your corn gluten meal. These and all we can use that. If you want, we can also help, sir. We do have got a good formulation and we do have got a feed. We are also supplying to the farmers. Little bit. Yeah, marine fin fish, we go to look at a different aspect, not like any other freshwater fish. It is a high quality, premium. Not all ingredients are available. So like this technique, this type of this one, we have to work.
So any other?
Thank you. Ma'am, last question for you.
Okay, sir.
Yeah. In your presentation, you said, the GM products across globe may not be the problem. But, regarding our shrimp exports, it's an international certification is needed. In that case, like, international certification like BMP or GAP, this certification, does it impact the GM products? That's a question number one. Can you throw about this?
Sir, we will have to look at a specific certification that you are referring to. But I would like to mention to you here that as you saw, it is all the countries where, I don't know where all you are exporting, but all these countries are using the GM soybean or GM products, sir. Even the European Union, earlier many times some people will try to give a propaganda that Europeans don't allow. But Europeans also, for the feed purpose, they take all the soybean, meal from Brazil, Argentina, and most of their food chains, they have actually, when they started using, they have informed their product this thing. So this specific certification, if you share with me, I will look at it and, get back to you.
Yeah, because why the doubt has come, ma'am? Because since last 6 years, some MNC company, the feed we used to import, that consignment used to get with, the BMP certification. it's the story of 6 years back. Once they started using the GM soya in their production line, then they stopped giving the BMP certification of their product. Because generally my exporter will get at least 10 to 20 cents each certification. Like farmer BMP certification, you will get 10 to 20 cents. Is feed manufacturers, if you'll give the BMP certification, you will get 10 to 20 cents more. Like our hatchery operators, they give in 4 segments, all 4 segments, if they allow, you'll get at least minimum 40 to 80 cents, depend upon the market demand.
Right.
If suppose they loses, that thing means it's an enormous amount per ton, they lose 40,000 to 80,000 rupees. That's why just can you clarify after some time also to me, Dr. Anjali?
So can you again tell me which certification? BFA you said?
It's a best BMP, GAP and BMP. It's an international certification, ma'am.
Right. We will look at it, sir.
Yeah. That's one thing. And ma'am, regarding means why we have got doubt about our so much demand of our Indian soya.
Yeah.
Means when our GM soya is there, why the either our South Asian countries or Western countries, why they are so crazy about our Indian soya import? Can you throw, if you got any information?
We are not a very major producers of soybean. Right. Definitely these organic, there is a separate lobby which is like organic producers. They look for some European people there. They ask for this particular, exports for soybean, the non-organic soybean. So as I told you, sir, when the genetically modified soybean has been adopted across the world, the major producers. So almost more than 80% of the soybean which is cultivated worldwide is 80%. 80% of that is genetically modified soybean. So there is remaining, maybe 15 to 20% in some countries, which would be using in-house. And then there will be this particular segments who are using organic, they certify their products as organic. They look for non-GM. Although there also, I would like to share with you that there has been a lot of discussion going on that, why should GM be considered non-organic? See, these organic standards were made many years back. And when you are actually using these GM crops, you are using less of the chemicals as compared to the regularly grown. So there is that kind of debate also is going on. But as you rightly said, we have to look at these certification systems and see that there should not be any restriction.
Yeah. Thank you, ma'am. Because our this thing, Indian farmers are producing almost 1 crore 20 lakh tons of soya.
Yes.
Yeah, in that almost around 30 to 40 lakhs, the demand is there. Since government restriction is there, that's why because initially they want to cater the Indian that meat producers. That's why they are not allowing them to export. They are only allowing them to export hardly 1 million to 1.5 million tons only. Right. That's why just just focus on that for before next meeting, ma'am.
So we will do that. And sir, to be this thing, if there is a very high demand for non-GM soybean for some particular, I would say that we should, this is a trade word, sir. They should make money there and maybe get a cheaper GM soybean for use in the animal feed. I mean, we have to see what is beneficial for us. Yeah, so there is always a certain segment, like we go in the market now,
we don't have, ma'am, we don't have any objection. Like Indian maize fish production, finfish production, where our Indian consumer anyhow that like cotton seed already we are using. Those are the GM cotton seed only. Like GM, so no problem. But we are worried about shrimp exports.
Right, very right.
Or tomorrow marine finfish exports.
Right.
These two areas, means our feel is that certification should not disturb. That is only the myth. Right. That's all.
Right. So, sir, I would just like to mention that we had a meeting, in CMFRI, where MPDA people also came and they also spoke about all these things, so we'll interact with them also and find out what are the standards and, how best we can make benefit of this. So any other participants, if they
Thank you. Thank you, both of you, ma'am.
Thank you so much, sir. Any other participants? Dr. Hari Babu or?
Yeah, yes, ma'am. Definitely, I feeling pride for your initiative, and BCL is to be appreciated for opening the discussion, and it is a long pending issue. We are almost, I feel personally negligent on the issue of the discussion for this GM carton. But my suggestion to you, madam, all the valid points raised by Dr. or IPR Mohan Raj Garu in your presentations. One suggestion, ma'am, for your in present that you are going to conduct around month end SEBA in SEBA 1 meeting.
Yes, sir.
In that meeting, we have to identify the action plan. What are the issues that are blocking for usage of GM products in our animal feeds, particularly aquaculture? And as raised by the point raised by IPR Mohan Raj Garu, we have to see that Seafood Aquaculture Alliance, so that is who are conducting the certification program, good aquaculture practices or best aquaculture practices. These certification bodies definitely they help us in clearing the doors or opening the doors for further advancement of the usage of this. And industry is very much looking forward, anxiously looking forward for the liberalization of some of these, so that cost reductions will be there, and ultimately farmer will be benefited for cost of reduction and feed sector. So action plan is very much needed, madam, on that meeting day. What are the issues hindering us? What takes us forward? Action plan. Thank you for conducting.
We will definitely look at, sir. Dr. Amba Shankar is here. We are going to have this meeting on 25th July. So I will send an invitation to all of you also, since we have your contact details. So please, if you are able to join, it will be our pleasure, sir.
Definitely, your activities will be strengthened, and you will help us. You are helping us, the industry. Definitely.
Thank you, sir.
Initiative is nice.
Thank you. Any other participant? If they have any questions?
Fisheries department officials, anybody? Anjali ma'am, JD sir.
No issues from department.
Yes, sir. Yes, sir. Okay. So I think if there are no issues, maybe we can close, and thank you so much once again to the department for facilitating this interaction. And maybe, if all of you feel so, we can actually have a more detailed in-person meeting also at Vijayawada with the shrimp manufacturers. So I will leave this option open to discuss all this in detail. Do let us know if there is a requirement for that. We can all sit together and understand more about these things. List down the issues after our 25th meeting. Once again, sir, if you are looking for a interaction with the industry, we will be able to facilitate that.
Certainly, madam, we will discuss with our commission sir and assistant director, madam, and we will let you know.
Thank you so much, and thank you to all.
Before that, 1 minute, madam. Just I wanted that 25th our physical meeting. I request both our IPR Mohan Raj Garu and Haribabu Garu and all other industry. Even I think state fisheries department also, please, you can also send the representative, because this is only an awareness. So today also we got some 2-3 good points both from the industry. So actually, people, if they can come and interact, it will be better, so that we can move forward at an earlier space. So that, because finally we are working for this for industry and the farmer. So the real input from people only will be helpful in finalizing this. So I request whoever is assembled, everybody, please, we will individually send invitations, sir. But please prepare on 25th, keep your calendar free, and then you try to make to SEBA Chennai, so that we can have further fruitful discussion, and then we can move forward. Whatever queries you got, with the right people will discuss. And then
Shankar sir, there is a small confusion is there. Madam mentioned Vijayawada and you are mentioning SEBA Chennai.
No, sir.
No. Two things I will clarify. 25th SEBA is there, that is confirmed. In addition to that, if we want one more meeting also at Vijayawada, we can plan. That is what Madam is saying.
No, whether the 25th meeting is at Vijayawada?
Chennai,
No,
Chennai, Siba Chennai.
Okay.
Siba Chennai. In addition to that, for example, those who cannot able to come, that is different. That we can. So what the Madam is trying to say, it is, this one. We can continue to have our dialogue and then we can continue.
In that case, last point from my side, a request to Dr. Ambashankar and Madam is, so nicely you have organized this meeting. Make interest in the people on 25th so that we wish to have one more meeting at Vijayawada.
Yes.
On 25th
No, please,
at
that's what,
Vijay-
sir. You also passed to, I request about IPR Mount Rajigar, please pass the message. The right people should come, sir.
Oh,
So
sir,
this
that's
type
right.
of input should come. It will help us so that we can also think on this one.
My suggestion to you and Madam is, let us make that discussions, deliberations on 25th, encouraging to have one more meeting at Vijayawada with industry people.
Definitely.
Definitely, sir. Okay.
Thank you, Doctor. Thank you.
Thank you.
Thank you, madam.
Thank you to all.
Okay, madam, bye-bye.
Yes, bye. We close the meeting.